And the first problem in this set of rapid fire for the 2024 10A, it's problem number 6. What is the minimum number of successive swaps of adjacent letters in the string A, B, C, D, E, F that are needed to change the string to F, E, D, C, B, A? Basically, it looks like it's reversed. For example, and these 4 examples, you should pay attention. They could be useful in your strategy. 3 swaps are required to change ABC to CBA, also reversed. 1 such sequence of swaps is ABC to BAC, A and B switching, then A and C switching to go to BCA, and finally C and B switching to go like that. It took 3. Because when they do these things, you might observe, well, A had to move from first position to second. That's always going to take a swap. And second position to third. And then I switch C and B to fix it. But it kind of makes us think maybe we could focus our attention on the A. In order to get it over to here, no matter what happens with all the other switches, we're going to need to switch A with B first. A has to move 1 move at a time to get over there. And so you say, okay, well, if A switches with B, then B will be here. And then A will be, it'll say like this, B, A, C, D, E, F. One way you could lose time is if you wrote every single step down in full. You kind of want to perceive what's going on so you can maybe avoid having to do that. So now when A switches with C, it looks like it's just going to build out all of these moves and put A at the end eventually. If I just keep moving A over every single time, and since A can only move 1 move per swap, it would make sense it takes 1, 2, 3, 4, 5 moves to get it into the final position. And with no other swaps taking place, everything else is just going to move over 1. So it takes 5 moves to do that. Now I need B to be next to A, but it's all the way over here. And we just play the same game again. B would switch with C, and then with D, and then with E, and then with F, and it's going to take 4 more moves. And then you're going to have A and B, and since nothing else changed, you will have everything else in the exact same order. They didn't do anything except switch with B. So clearly C's on the outside. Then when D and B switched, D is next to C now. They don't do anything else. That's what it is. And now to get C over to the F, you're going to need 3 moves. 1, 2, 3. And you can see what the game is. We're simply doing triangular numbers, otherwise known as the sum of the numbers from 1 to n. And so I'm not going to explain why they're triangular right now. You have 6, 6, and 3. You're going to get 15. And that will be the answer. Let's get to problem 7. So let's get to problem 7 now on the 10A and the first of your rapid fire for 6 through 10 on the 12A for this year's 2024 test. The product of 3 integers is 60. This is a really interesting question, and for those of you new to the competition series, you might notice a few things in here that happen as you're going through the problem. Even it caught me for a second, and I'll get to what I'm talking about in just a moment. So the product of 3 integers is 60. What is the least positive sum of the 3 integers? So product of 3, it makes you think you probably got a prime factor. For those of you who are experienced, this should be done at a glance. 4 times 3 times 5. So that's going to be equal to 60. So now if I'm picking 3 integers, the product of 3 integers is 60. And we say, okay, I want the least positive sum of the 3 integers. And by the way, what I'm doing is exactly what I did. That I did not perceive things right away. It took me a second to realize once I kind of just took some path and then realized what I could do differently to make it better. Let's see what I'm talking about. Maybe I do 4, 3, and 5 as my integers. And I got, okay, well that's a sum of 12, but that's not on here. And furthermore, everything's a lot less than that. Why? So then it was like 2 times 3. Okay, well I guess I could do 2, 6, and 5. And again, I'm getting 13, which is larger than 12. It's not getting any better. It's also not one of these answers. And why are these still? How could I ever get a sum of 6 or 5? 5 alone is 5 already, and you've got the other... Oh, wait a minute. Did they say positive? The product of 3 integers. Crafty. They did not say positive. The test makers know what a lot of students reading will infer. And luckily for us, right, or you, if you do the same thing, they didn't put anything like 12 or 13 on. Not that I would have accepted it right away. I would have still thought about it and challenged my thinking because I want to second guess myself. And so, but they didn't put that, so none of you could have gotten trapped with it nice enough. So if you're going to get these, obviously we might be able to use a couple of negatives. Now, if I have 2 negatives, I'm going to need the positive number to be larger than the sum of the other 2. So for example, this is the positive number here, the larger one has to be the positive. All of this reasoning you kind of have to generate on the test. What is the mechanism by which you're going to answer this? I need this largest one to be bigger than the other 2 negatives. That just makes sense, right? If I had this one negative and that one negative, the sum would not be positive. And this is also what they do. The least positive sum makes you think, oh, they're all positive integers. They didn't say that. It's the least positive sum, okay? So they do that a lot. Let that be your lesson if you're new to the contest about them doing those kinds of things. So we have to have this. Let's try this 6. It's really close, except that if 2 and -5 were both negative, I get -1 as a sum, and that's not a positive sum. So at this point, we're going to need to try again. Obviously, 6 cannot be the largest number. I need to create something larger. And if I did 2 times 3 to get that 6, what's the next smallest thing I can create up here? It's probably 2 times 5, which would equal 10. So if I did combine one of my 2's with the 5, that would leave 6 and 10. How am I going to get? Oh yeah, 1. 1 works just fine as one of our integers, making this one negative and that one negative. And the least positive sum, -7 plus 10, is 3. Now, you might be curious, would there be some way to get a 2? I would need, how would you get that? You could check around for it again, but just trying to make the largest number as small as possible, yet still larger than the sum of the other 2, you're not going to find anything that gives you a 2. And again, we get 5 here is just 5 by itself. 6 is the next smallest thing above that. Could I create a 7? No. Could I create an 8? No. Could I create a 9? No. There's not 2 3's. 10 is definitely the next smallest number that we could make larger than the other 2. You can be pretty highly confident in your answer at that point. But don't be worried that you took an extra 30 seconds to check. That's what the test is all about. You definitely don't want to lose 6 points because you didn't check. Let's get to the next one. Continuing to the 2024 10A problem 8. Amy, Bomani, Charlie, and Daria work in a chocolate factory. Charlie and the chocolate factory. On Monday, Amy, Bomani, and Charlie, or A, B, and C as they're known amongst themselves, started working at 1 p.m. and were able to pack 4, 3, and 3 packages respectively, which means in the same order, 4 with A, 3 with B, 3 with C, every 3 minutes. Okay, what do we do with that? We should make some sense of it. Amy does 4 packages every 3 minutes. That's 4/3 of a package per minute. 4/3 of a package per minute. I guess I don't need that. Package per minute. Bomani does 3 packages per 3 minutes, or a package a minute. So her rate is 1 per minute, and Charlie is 1 per minute as well. At some later time, Daria joined the group. What are we probably doing here? You're probably doing the work together formula. In Chapter 3 of Volume 1 of AOPS, they cover this exact concept. And the way that I teach it in my classes, which you can sign up through my website if you'd like to go through them with me, the way that I show it in my classes for that formula, it's not shown this way in the book, is that 1 over A times H plus 1 over B times H equals 1 complete job. And so H is the hours they would work together, but A is the hours it would take A alone. And of course, hours can be changed to minutes and so on. There can be more things. You have to be able to modify the basic formula. And so since M is minutes, A is the hours it would take A alone. Let's say A took 5 hours to do something. Well, then what is 1/5? 1/5 is the amount of the job that A would get done per hour, right? If it takes them 5 hours, they get 1/5 of the job done every hour. And then by multiplying that by the number of hours, you can see the portion that A gets done during some allotment of time. So we're just going to take this basic skeleton formula and be able to modify it if you understand it. And if you went through my class, I hope that you got this question right, because we did cover this concept in the class. It would be 4/3 per minute times the number of minutes is what Amy does. Bomani does 1 per minute. And so does Charlie. That's their combined effort, okay? And on Monday, it says that sometime later, Daria joined the group and Daria was able to package 5 packages every 4 minutes. But Daria's not working for the same amount of time. So we're not going to be able to put Daria on here yet. Together, they finished packaging. We could put her there, but I don't want to. They finished packaging 450 packages at exactly 2:45 p.m. So was there any time that A, B, and C were not working? No. Which means if they started at 1 p.m. and they go till 2:45, that's 60 minutes plus 45 minutes, they're working for 105 minutes. So we know what this number is. Furthermore, I can combine all of this to 7/3, 10/3 M, and I know what that M is. Again, the M is 105 because they're always working. Daria is not always working though. 3 goes into here 35 times. That means they will do, A, B, and C will do 350 of the packages. Now we have all that information. We keep going. Together they finished packing 450 packages at exactly this time. So if A, B, and C are doing 350 of the 450, what is Daria doing? 100 of the 450. So then you're going to say, okay, well, what's Daria's rate? Essentially, this is the rate of what Amy is doing. It's a lot like rate times time equals distance, but instead it's rate times time equals work completed. Very much the same concept. So now we have 100 packages for Daria to do, and Daria does 5 packages every 4 minutes, so 5/4 of M. Well, clearly we're going to multiply this by the reciprocal to find out how many minutes Daria is working, because Daria does not do the same amount of time. She joined later. So 4/5 of 100 is 80. Daria was working for 80 minutes. So we go backward an hour to 1:45, and then you go backward 20 more minutes to get your full 80, and you will be at answer choice A. Let's get to question 9. And question 9 we are doing now. In how many ways can 6 juniors and 6 seniors form 3 disjoint, there's the word, we don't get that often, just means there's no overlap, 3 disjoint teams of 4 people, so there's 12 total and there's 4 per team, so we're going to have 3 teams, so that each team, pause and make sense as you read, you'll be able to work faster through the problem. So that each team has 2 juniors and 2 seniors, again, confirming the 4 people. That's it, that's the whole question. So how do you begin? I did spend a little bit of time on this thinking about the best strategy that to employ before I finally said, well, let's call the juniors will be A, B, C, D, E, and F, and we'll make the seniors 1, 2, 3, 4, 5, and 6. Just easy things to set up. And I said, okay, how am I going to do it? Should I pick the teams, like what juniors go on which team? But then I run the risk, if I do that, of overcounting. Because let's say I put the teams as A, B first, C, D second, and E, F third. But then a different way would be that I get AB first, EF second, and CD third. And those are actually the same teams. They're just in a different order. They're not called team one or anything like that. So is that really what I want to do? And so you say, okay, well, I don't want to risk overcounting. Is there something else I could do differently? And that's when I said, well, why don't I do fixed position? Basically, A has to be on a team no matter what. So put A's team, the A team, and you're going to pick who's going to be A's partner. It doesn't matter what order the team's in or what they're called, A has to have a partner. And so you have 5 choices for A's partner. And you start thinking, I bet we're doing fundamental counting principle. And it works just fine. Let's go ahead and put the 5 right here for the 5 choices of A's teammate. Choices of A's teammate. Okay? Now, once that decision is made, let's say I chose D to go here. Doesn't really matter. Okay? The next thing would be, of the 4 remaining players, you get another fixed position. It's important that you understand you don't put a 4 here. Because it doesn't matter who's left. You're not choosing any one of those players, really. You're fixing them as mandatory being on some team besides A. For example, person B has to be on a team. I don't pick B, I'm taking it and I'm saying whatever B's team is, because B was not the selection for A, B has to have a teammate. And I do choose B's teammate. There is one person out of the remaining 3, C, E, and F, that can be B's teammate. So I don't put this 4, but instead I put a 3 for the choice of who will be on B's team. Well, how do you know B wasn't with A? This is just a sample setup. It wouldn't matter who you put here. There would be 4 other players. You pick one of those 4 and you say that person needs a teammate. So it doesn't matter if it's B or anyone else. By symmetry, it's all the same situation. And so I say, okay, well, they have 3 choices. Let's go ahead and randomly assign them one. We'll just put B with C. Okay? Now, at that point, who's left? E and F. And they don't get a choice. They are on a team because everybody else on the juniors as part of a team already. So guess what? You're getting paired up with E and F, whether you like it or not. That's how that works. Now, these are the teams, and they've been set up for the juniors only, and there's no risk of overcounting. A had to have a teammate, one of the other 4 had to have a teammate, and the last one is by default. Now, all we have to do is place these over here. And whatever team A is on, they're going to choose 2 seniors. How many ways can you do that? Does it matter the order that I pick them in? These are questions you have to ask and you have to be able to answer. No, the order of the senior selection doesn't matter, but which 2 it is matters. Therefore, we use a combination. 6 choose 2. You should have in your small notebook that n choose 2 is equal to n times n minus 1 over 2. So 6 times 5 over 2 is 15. So now we're at 15, and what's left? Let's say you put senior 3 and senior 5 on AD's team. Then who goes on BC's team? Well, we have 4 players left, and you're going to choose 2 of them, and the order does not matter that you choose those 2 players in, just that they are on this team. And of course, there are 6 ways that you can do for choose 2 with the same shortcut formula. And the last 2 players just go on EF's team with no real choice to be made. This will be all of it. You have 15 squared, otherwise known as 225 times 6. 6 times 200 plus 25 will be 1200 and 150, giving you a total of 1350. Let's get to problem 10. And the final problem in this rapid fire set on the 2024 10A, it's problem 10. Consider the following operation. Given a positive integer n, if n is a multiple of 3, then you replace n by n over 3. If n is not a multiple of 3, then you replace n by n plus 10. Then continue this process. For example, beginning with n equals 4, this procedure gives 4, 14, 24, 8, 18, 6, 2, 12. Okay, why would that work? 4 is not a multiple of 3. We add 10. We add 10, a multiple of 3. Now you divide by 3, add 10, divide by 3, divide by 3, add 10, and so on. Suppose you start with n equals 100. What value results if you perform this operation 100 times? How are you going to do that? Honestly, you're just going to make a chain until you find some kind of thing that you can act on. Hopefully, a pattern develops as you go. So 100 is not a multiple of 3. So you're going to go to 110. I'm going to call that a sub 1. It is the first operation. That is not. If you just write the list and don't call that A1, you might think of this as A1 and then you might make an error. So you want to kind of note where the first turn is, okay? So then 110 is there. It's not a multiple of 3, so you go to 120, then you go to 40. 40 is not a multiple of 3, you go to 50. 50 is not a multiple of 3, you go to 60. Then you go to 20 because you're going to divide by 3. Then you go to 30, then you divide by 3. Then you add 10. Then you add 10, and then you divide by 3. I think we found what we're looking for. If you cut off, we're just getting 20s, 30s, and 10s. Let's cut off right here and get a peak. 20, 30, 10. 20, 30, 10. And so it's just going to repeat ad infinitum. So then what? A2, A3, A4. That is the fifth iteration of our 100 operations, the 100 times we have to do it. So we would have to do it 95 more times. And we're doing it in groups of 3. So this would be your 3rd, your 6th, your 9th, and all the way up to the 93rd step. This would be the step 93 because that's a multiple of 3. And all multiples of 3 will be here at this 10. Just repeat, 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 right? So like this is the 8th and the 11th, but really we're thinking about it as, because you're at 5th term here, you're just thinking you have 95 terms to go and you're counting groups of 3 and you want to get to the end quickly. So since 93 is a multiple of 3, you'll still have 2 moves to go and they will be 20 and then 30 to get answer choice C. See you in the next rapid fire.